Today we're going to continue talking about different segments within or outside of the circle. The first property I want to show you would be two secants intersecting outside of the circle, so at point E here. The relationship is not that these are necessarily congruent in length, but that pieces of them are proportional, so it all relates back to similar triangles. The other, and we'll talk in length about this on the back for sure, the other relationship would be a tangent and a secant meeting outside the circle. So in this case at point A, it looks like a different relationship, but we can use the same strategy every single time. So I'm first going to prove why this works. We'll prove the first example, and then we're going to try some numeric practice on the back. So looking at the original picture, the first picture, it's again repeated here. The trick is finding similar triangles, which is easier said than done. I could have drawn triangles here or just a triangle there. I could have connected those to make a triangle. I purposely connected these points to make that length and these points to make that length. And this is what I want you to notice after you do that. So once I did that, I then had angle 1 and angle 2 here. I'll mark them with the same marking. They both happen to be inscribed angles that subtend or share or intercept any of those words or across from the same arc. So they are congruent. And also this angle E here, this is reflexive in both of these triangles. So that was enough evidence for me to prove that triangle AED and triangle BEC are similar by angle. We're bringing back an idea from marking period 3 that if you have similar triangles, the sides are going to be proportional. So I carefully, again, chose sides here that I wanted to relate in the end. So I chose E to A, either way, relating to E to B, and that's going to have the same ratio as, and this is kind of, be careful here, back to this triangle, E to D to E to C. So I said similar triangles, corresponding sides are proportional, and then we did a cross multiplication step. With these types of problems, you're welcome to set up triangles every single time. I would recommend not doing that. I think it's much easier to memorize the consequence. So the consequence would be take the outside, okay? So for instance, the outside piece of the secant would be E to C, and multiply it by the whole secant. So there's my outside E to C times the whole secant E to A, and that will end up being equivalent to the outside piece of the other secant times the outside piece of that, times the whole piece of that secant. Let's try some numeric practice. I think that will make even more sense. So this is what I notice. I have two secants intersecting. The outside piece of this, so not in the circle, would be 5. They didn't tell me the entire length or the whole length. That's okay. I just added the 5 and 9. I multiplied those together here. Same thing with the other secant. The piece outside of the circle happens to be 6. The entire length is 6 plus x. So I set up that piece there. I did a little bit of distribution, solved the equation. I got 17/3 for x. So we've exclusively been talking about secant and secant relationship. What if you have a secant and tangent relationship? Very, very, very similar, no pun intended, idea here. So with the tangent part, I'll go through that first. The outside piece happens to be 6. The whole piece happens to be 6. So I literally just multiply 6 and 6. So you could write that out. I'll try my best to write that here. So you could say 6 for the outside, 6 times the whole, or just skip to 6 squared, equals, and then same strategy with the secant. Piece outside the circle happens to be 2. The entire length is 2 plus x. And again, once you have that set up, fairly simple linear equation, go through distribute, rearrange, and you'll have your answer. And then lastly, and again, I try to choose ones that are a little bit more complicated so the homework feels easier. You have a secant and a secant. The outside piece here is 1. The whole length, they made me add. Sometimes they won't, but I had to add again here. It would be 4. So I position that here in my equation. Doesn't matter if I did that first either. I notice the markings here. This is X and this is X. Simple mistake students make, or common mistake, would be to say this is X squared. But remember, you're just adding those pieces, so that's 2X. One strategy I would do, label your diagram before you even go to your equation, because here you have addition, whereas here you have multiplication. Sometimes that can mess with your head. So the outside piece happened to be X. The entire length is 2X, or the whole length. And then I'm multiplying now, so I got 2X squared. I decided to divide the 2 over and then take the square root. It's a little bit more complicated than working with the intersecting chords. So again, please let me know if you have any questions. Thanks for watching.